Okay, so today's video we'll be solving questions on logarithms. Okay, so fast forward, our first question, we have log to the base 4 of x squared minus 2x equals log to the base 4 of 5x minus 12, and then we have to find the value or the values of x. Okay, now the first thing we are going to check is to see if the logarithms are of the same base. These are the bases of the logarithms. So the logarithm at the left hand side is of base 4, the one here is of base 4. Okay, so they have the same basis. Now, because there are single logarithms on both sides of the equation, we can take antilog on both sides. Now, taking antilog means we are getting rid of the logarithm. Okay, now you can only take antilogs when the logarithms are of the same base and they are also single logarithms on both sides. Okay, so we have single logarithms on both sides and then they are of the same base, so we can take the antilog on both sides. So taking the antilog gets rid of the logarithms. Okay, then you're only left with these expressions. So taking antilog, we get x squared minus 2x equals 5x minus 12. Okay, then we just simplify this into a quadratic equation. We solve for the values of x. Okay, so we get this plus 12 equals 0. So we can factor it out. We want two factors of 12, which when added we get minus 7, but when multiplied we get positive 12. Okay, so that's definitely negative 3 and then negative 4. So we get minus 3x plus minus 4x plus 12 equals 0. So we can factor out x, we get x minus 3. We can factor out minus 4, get x minus 3. X minus 3 is common, so we factor that one out. Then you are left with x minus 4 in this bracket also. So x will be equal to 3 and x will be equal to 4. This will be our final answers. Okay, now one thing about logarithm is that mostly the final answers, sometimes, not mostly rather, sometimes it's not all of the solutions you get at the end that satisfies the original equation. Okay, so it's mostly advisable to, after finding the values of x, you test it in the original equation to see if it satisfies it. Okay, so we are going to test. Let's say if x is equal to 3, then for the left hand side we will have log to the base 4 of 3 squared minus 2 multiplying 3. 3 squared is 9, 2 times 3 is 6, so 9 minus 6 giving us 3. So left hand side will be log to the base 4 of 3. Okay, now taking the right hand side, so that one is log to the base 4 of 5x minus 12. Okay, well, x is 3, so we get 5 multiplying 3 minus 12. 5 times 3 is 15, minus 12 gives us 3, so we get log to the base 4 of 3. So you can see that 3 satisfies the original equation, so 3 is part of the solutions. Now let's assume that x, now let's take x to be 4. So that will also be log to the base 4 of 4 squared for the left hand side. 4 squared minus 2 multiplying 4. 4 squared is 16, 2 times 4 is 8. 16 minus 8 gives us 8, so we get log to the base 4 of 8. Okay, then for the left and the right hand side, we get log to the base 4 of 5 multiplying 4 minus 12. 5 times 4 is 12, 20 minus 12 is 8, so we get log to the base 4 of 8. So you can see that x is equal to 3 and x is equal to 4. Both of them satisfies the original equation, so they will be our final answers. Okay, so our next example. For our next example, we have log of 6x minus log of 4 minus x equals log of 3. Okay, now we have solved for the values of x, the value and the values of x from this equation. Okay, now whenever you have any logarithm without a base, it is considered to be in base 10. So let's say you have log 3, just log 3 without a base, is the same thing as log to the base 10 of 3. Okay, now just as in the first example, we have to take the antilog on both sides, but here's the case, we don't have a single logarithm on both sides. So what do you think we should do? We have to merge these two logarithms into a single one, then we get single logarithms on both sides of the same base, then we take the antilog. Okay, so have log of 6x minus log of 4 minus x equals log of 3, right? So we know because you have the same basis, properties of the laws of logarithm. Whenever you have two logarithm of the same base and they are subtracting, that means the terms in the brackets, or the terms you are finding its logarithm, will divide. Okay, and that is one of the laws of logarithm. Okay, so this is a very similar situation. Log of 6x minus log of 4 minus x equals log of 3. So we have to merge these two logarithms into a single logarithm. Okay, so they are the same base, which is base 10, and then they are subtracting, so the terms in the bracket will divide the first one before the second one. So we get this equals log of 3. Okay, now we've now gotten a single logarithm on both sides, so we can take the antilog. So taking the antilog, we get 6x all over 4 minus x equals 3. Right, now we can multiply both sides by 4 minus x so that they will cancel out, or you can cross multiply so that the 4 minus x multiplies the whole of this 3. Okay, so we get 6x equals 3 multiplying 4 minus x. Okay, now we can divide both sides by 3. 3 cancels out, we get 2x over here. So we get 2x equals 4 minus x. Okay, then we can bring this to this side. So we get 3x, it's 2x plus x, which is the same thing as 3x. So 2x plus x equals 4. Then we get 3x equals 4. X will finally be equal to 4 over 3. Okay, so let's test it to see. X is 4 and 3. Replacing x with 4 and 3 over here. 3 goes into 6 twice, so 2. 2 times 4 is 8. So replacing x with 4 and 3 here gives us 8. So we have log of 8 minus, replacing x with 4 and 3 over here, we get 4 minus 4 and 3. 3 times 4 is 12. So we get 12 minus 4 and 3, which is 8 over 3. So minus log of 8 on 3. Okay, now is equal to log of 3. So let's simplify this log to see if we get log of 3. So we have log of, because they are of the same base and they are subtracting, they will divide. So it will be 8 divided by 8 on 3. Okay, now we want to introduce the multiplication sign. So times, then the 3 and then the 8 interchange their position. So 8 and 8 cancel out. We have log of 3. So it means this answer is correct. Okay, very well. Our next example. For our next example, we have ln of x plus ln of x plus 3 equals ln of 20 minus 5x. Okay, now ln is the same thing as log to the base of e. Okay, log to the base e is the same thing as ln, and it's termed as the natural log. Okay, so in the same way, we have to merge this to a single logarithm, same ln, so we can take the antilog. So in this case, they are adding. Okay, so if the subtraction was division, then definitely the adding will be multiplication. Okay, it's one of the laws. So the other law also states that if you have logarithms of the same base and they are adding, then the terms in the bracket will multiply. Okay, so we have this x multiplying x plus 3 equals ln of 20 minus 5x. And we can take the antilog on both sides. So we get x multiplying x plus 3 equals 20 minus 5x We can expand this bracket, we get x squared plus 3x. Move the 5x to the other side, get plus 5x. Then move the 20 also, we get minus 20. Okay, so we get x squared plus 8x minus 20 equals 0. Okay, so we solve this quadratic equation. So in this case, we have we want two factors of 20, which one added we get positive 8, and then which one multiplied we get minus 20. Okay, so that's definitely negative 2 and 10. Okay, so we get x squared minus 2x plus 10x minus 20 equals 0. We group them, factor out x, we get x minus 2, factor out 10x minus 2 equals 0. So we get x minus 2, x plus 10 equals 0. Okay, so our x will be equal to 2, and also x will be equal to negative 10. Okay, now this is one of scenarios I was explaining in the first example. We have two solutions, x to be 2 and x to be minus 10. Okay, now if you have to test it, let's test the minus 10. Natural log of minus 10 in the real number system doesn't really exist. Okay, in the real number system we can find the natural log of negative 10. Okay, so in this example, x equals minus 10 will not be considered as part of the solution because it doesn't really satisfy the original equation. I mean, if you merge it into this form, then I think definitely will satisfy it, but that's not what we want. We want to see if it satisfies the original equation. Okay, so in this case, x equals minus 10 is out, so our x will be equal to 2. If you get it in this form, then obviously the other solution is okay, accepted. But either ways, let's test it and see. X is equal to 2, so we get natural log of 2 plus natural log of 2 plus 3 is 5. Okay, so that means if you have to merge this, we get natural log of 2 times 5. They are added, so we have to multiply the 2 and then the 5. So we get ln of 10. Let's consider the right hand side also. That one is 20 minus 5 multiplying x, so 5 multiplying 2. So get ln of 20 minus 10, which is the same thing as ln of 10. Okay, so both sides are satisfied, so it is correct. Okay, our next example is 4. It's example 4. Okay, let's move on. I don't remember the number. Okay, so our next example, we have log to the base 3 of 25 minus x squared equals 2. Okay, now we don't have two logarithms on both sides. Okay, so how will we take the antilog? Now, one way to take antilog is let's say we have log to the base a of x equals b. Okay, so one of the properties of logarithm, x will be equal to a raised to the power of b. Okay, so this base of the logarithm here will travel to the other side and become a base over here. Then the one we have at this side becomes an exponent. Okay, you can actually prove it. It's very simple. You have log to the base a of x equals b. Okay, we can write this b over here to be in the same, like as a logarithm in the same base a. Okay, so b can be equal to log to the base a of a. One of the properties so states that if you have logarithms whereby the one you are finding logarithm is the same thing as the base, it is definitely 1. So b is the same thing as this multiplying b. Okay, so b is equal to b multiplying log of a to the base a, because the whole of this is 1, so it gives the same thing as b. So it's the same thing as b log to the base a of a. Okay, now another property of logarithm so states that let's say if we have n of log a of x equals, let's say b, this n is just can be transferred to this side. So we get log to the base a of x to the power n equals b. Okay, so the same way we can transfer the b to this side. So you have this log to the base a of a raised to the power b. Now they are of the same basis. Okay, so we can take the antilog, so definitely x will be equal to a power b, which is the same thing as moving this to this side. Then this one becomes an exponent, this one becomes a base. Okay, so That's why I wanted to illustrate. Okay, so we are using the same approach. So is either we write these two as this, then we move this to this side, giving us a 3 squared over here. Then we take the antilog on both sides. So we get 25 minus x squared equals 3 squared, which is 9. Then we get 25, move the 9 to this side, minus 9 equals x squared. Then we get 16 equals x squared, square root both sides. X equals plus or minus 4. Okay, in this case both solutions are accepted because minus 4 squared is 16. 25 minus 16 gives us 9. Okay, log to the base 3 of 9, so 3, so it satisfies it. Okay, or you can just 25 minus x squared, just transfer this 3 to this side, assume there's nothing here, it's just 3 or 2, sorry. So you just transfer the 3 to this side, so we get this equals 3 squared. I mean, it's the same thing as this one, so we definitely arrive at the same solution, plus or minus 4. Okay,